The measuring terminals of the ELM3 series can be combined with the other more than 800 EtherCAT terminals almost free, depending on the requirements on the DIN rail in the control cabinet. Here we see such a typical station. We have here standard AR, we have a field bus master and a measurement terminal. Almost all signal types commonly used in the manufacturing industry and test bench can be connected to the measuring terminals with their fast and high precision analog acquisition. AC/DC voltage up to 60 volt, thermocouples and RTD temperature sensors, vibration sensors and so on. The terminals are adjustable via EtherCAT and supply their up to 50,000 values per second and channel to the central controller. This controller can be TwinCAT or another automation software with an EtherCAT master. The group of measurement terminals has been significantly expanded in the last years. Without the special variants, there are now 25 measuring devices plus system components such as couplers, power feed terminals and the ELM2 multiplexers. The ELM3 measuring devices are currently divided into two classes. We have here the fast basic series ELM3xxx with 10 up to 50,000 samples per second and simultaneous sampling. And we have the economy series ELM3xxx with 1000 samples per second and internally multiplexed. Let's see now in the technical details. Let's follow the data flow inside of these modules, how the measurement data are processed. In the beginning we have a hardware filter which protect against aliasing effects. Then we have the ADC with 24-bit resolution and fixed sample rate. We have then a zero offset block where we can eliminate the offset. Then the user can decide if he makes an AC or DC processing of the measured values. We have temperature transformation for RTD and thermocouple sensors. And in the next step we have our peak hold for detecting minima and maxima of the measured value. And then we have our filter block. We have here the filter 1, where the user can free download any filters, bandpass, low pass, whatever, designed also with the TwinCAT filter designer. We have a two-stage integrator and differentiator in the firmware, and then the decimation to sample down the sample rate when a lower sample rate is required from the controller. And then in the end, therefore, a second filter station, absolute free, configurable by the user. And then in the end we have a range check for overrange detection, for example, true RMS calculation. We have a scaler inside for transforming the measured value in a linear or in a table way. We have Tara for weighing applications, for example, and in the end the process data are transported over EtherCAT to the controller. So now we have gained a first insight. The integrated measurement technology can thus safely form a solid foundation for data processing and machine learning in your plants and test benches as well. We would be pleased if you would involve us in the solution of your metrological tasks.